Hi, today I wanted to talk about historical data gathering and data mining. Now, IG's API allows you to gather historical data, but there are a few things you should know. Each API key is limited with 10,000 data points, meaning you can't get more data than 10,000 points per key. So the solution to that is generate more keys. Another thing to bear in mind is the demo account is not a real reflection on the live account, where data changes can happen in the demo account, so it would be best if you use the live account to get your historical data. So let's get started. So IG has a project on GitHub that has pre-made code to allow you to use Python to interact with IG's trading platform. Now you can get the code from another video I showed how to actually get the code and where the link is on GitHub, so you can just kind of navigate there on my channel. Now if you have a look at the inner workings of some of the sample projects that IG has, you can work from there. If we look at the sample project, you can see if you go to trading_IG and you click on rest.py, you can see this is an implementation of historical data. So you can see at top you'll basically have these imports, which are basically getting the file that has all the REST implementation to interact with IG's trading platform and their API. So you've got that, you've got this. You then create objects so in this case you're creating an object to show how long your IG object is going to stay live for. You've got the IG object here, which is basically your credentials. You then create the session. You then have this epic key. So that's basically an individual instrument, a unique identification code for that. You've got a resolution for that, so basically how precise your data points are. So this is per day. You then have this value here saying how many points you want. You then use this to, so in this case you're saying get me the historical data for this epic per day and going back by 10 points. So in this case it will be 10 days. And then you can print the response out. So if we run this, you can see here it returns us an object, which is I believe it's a dictionary. Actually, I believe they return back a munch object, which is similar to a dictionary, it's just easier to work with. So that's why IG chooses to do that. You can see here that the data is there. They do the data separated by bid and ask, and the data object is returned back in a data frame. So although this will probably be a JSON object, so from a munch to a JSON object, and then convert it into a dictionary or map. When you get this data, it will be in the form of a data frame, so you'll have to work with it that way. Another thing to note is the allowance. So each account, as I told you before, that has an allowance of 10,000 points, and you can see here from me doing the transaction or me doing the process of running the functions that I have, it has reduced the allowance to 9,970. So I've run some other processes before to reduce that allowance a bit more, so that's why it's a bit lower than expected. Otherwise, 10 points, 10 minus from that, 990. 9,990. Yeah. Okay. So that's a simple case of how to get historical data. So the idea here is that if you followed along from another video that I made on my channel on getting epic codes for all IG instruments, then this will be more relevant to you. So essentially you can navigate to it on my channel, but essentially I got all the possible epic codes that you can get off IG's trading platform and create a file based on that. And that gave me some details as in what the instrument epic code is, its name, and a few other details. But those are the main two that are quite important right now. So So in this way we can get all historical data for every epic code on the IG's platform. Now to do this you need to have quite a few API keys, and it's worth bearing in mind IG doesn't really know about this. Well, they do know about this, but in this way I'm bombarding IG's API quite heavily. So when doing this, it's worth just bearing that in mind, because what people tend to do is when they realize something's being bombarded, they try to make it more difficult for people to do so. So they might end up changing the API later down the line. But for now, just be a bit cautious with it. But yeah, I'll explain how this works. So this is my code. So you can see similar parts here where we're getting functions from the trading underscore IG import, which is basically this file in the trading API REST. It's basically that. So yeah, so we've got a login here. So what I'm essentially doing is I've got an increment API key function. Now that's quite important here. So I have a bunch of API keys. That's not correct. I think it's about maybe 10 or 15, something like that. So I'm basically getting these API keys. I'm looping over the file within that, and then returning the key out and breaking through this whole if statement here, and then checking if that API key works here. Now, if later on along the line it throws an error, we then go back into the login function here. You can see here. So basically I've got an exception statement, login, and we basically run through that function again, and this time we would remember the key we were previously on, because we have a global variable there, and we increment that value by 1, and then go into the file again and get to the line just after the previous key that we took, and then we take that line, exit out its if statement, and then try another key, and with that key in mind try it again, and hopefully that works. If not, do it again. So it'll keep going through that list until you get to a point where there is an API key that has a number of data points valid that you can use. So you keep going through it until you get to the key that works for you. So yeah. So that's what that part does. You then create an object here, an IG object. You then, so you can see here that we've got this section. We create the IG service, and then we go into our main function here. You can see here is logging, the login object that we talked about before. Yeah. And then we're getting the file I created that has the epic codes for every instrument on IG's exchange. Because we've saved this file, naturally when you open a file back up, it does give this horrible excess column. So we're removing this column. We then convert the epics to a list. We then convert the names to a list, and we say we want a resolution of 5 minutes. We then have a date counter here. So, for example, if we say in the range here that we wanted 10 days, what this was doing previously, that I've commented out, was we would say we would start for either 0 or 1, and then we would add that onto this date value here, and then we would append on 1 day on from that. So let's say we're starting from 1. So we'll say like either we're doing a range from, so something like range 1, 10, Okay, so stop. Yeah, I think that's it. Otherwise, you can do something like that, which basically means start from 1, end at 10, and do each step by 1. So you would have something like this, basically saying you're starting from 1, going on to 10. And what that would do is it would put a 1 here, and then you would add that 1 on. You would add 1 onto that 1, making 2. So you would have 2020 of 11, 0, 1, and 2020 11, 0, 2. And then you run for this function, going through each list of epic, and generate your historical data that way. So that would be for each day. That was when I was doing 1 minute intervals. So another thing to bear in mind is that the resolution for 1 minute intervals can only do per week. If you do 5 minute intervals, you could do about a month worth of data per instrument that you can go behind of. So you can see here we're going through each epic in that list. We're basically getting the index code for that epic, saving it in this variable, so the name. That's just to print out the name that we know. The number of data points I put here was 9,000. The limit's 10,000, so I just thought it would be that way I'm not completely bombarding each API against IG's trading platform. So I felt as long as there's some data there, it will still be useful. Some data points for each API key I had. So you can see here we're fetching the historical data by epic and date range. So we're saying here getting the epic at the resolution, which is 5 minutes, the start date, which is the 01 we talked about, and the end date, so that will be the 02. That will then return this object here, response, and if an error occurs, we check firstly if our error is equal to historical data allowance limit. If that's the case, then we do the login object. So that means that our API key has no more historical data we can take from it, or has reached its historical data limit for its value. Or we have an invalid token, which is kind of the same thing. Error security generic, it's the same thing as well. Exceeded API key allowance, same sort of thing, but just reworded. And if the exception is not that, then we assume it's unknown. We break from this while loop, because sometimes there are cases with IG that there's just simply no data available for that key, or just that epic key doesn't exist on their historical data platform, and they throw an error. Yeah, so you have to deal with those sort of issues as well. So if your response, so that breaks out of that, then it says if your response is equal to none, then continue. So essentially if there's no data available, then continue and there's no errors thrown. Print the response to kind of give you visual feedback. The data frame, get the, so in this case we are caught it as a dictionary. So get the dictionary as response, and then you can see the data frame there, and then we save that value to file. So you can see here we are replacing the name, replace the / with the sometimes if a value is nested in another value, so you can, so for example like options, you can have options and then they sometimes give you a / then the value, so gold for this month and such. So to change that you can put a dash between it, otherwise saving that file will, in Python, will end up making a folder and then a file, which is just confusing. So it's better to just change it to a dash. You then have the location of where you're going to save it, the start date and the end date. We're doing a check here to see if that dictionary, if that directory exists. If not, we create a semi-directory here, and we then make the directory further, because we've got loads of dates. So you would want to make the partial section here first, the partial directory, and then later on, if you are doing multiple dates, you can create the yeah, so you can do the rest of it later on, which then goes on further to create the start date and the end date, because you're creating a new directory. So it's just easier doing it this way. There's less errors that I saw were thrown. The full path here is the name, the resolution, the ID to kind of isolate each epic. So you can, when you do come around to getting the file, you can actively see the epic code without having to dive into the contents of the file. So then here we're saving it as a data frame, and then we just loop back around and keep going through it until we get to what we want. Yeah, so we keep going through until we get to the final date, if we are doing that sort of method of it. Yeah, that's pretty much it. So just to give you an example of what it might look like, if we go to data, no, okay, so it's in a different file. So if we go to our thing and we go to data, and we go into IG instruments, we go to historical data, we can see here we've got different types. If you go to our 1 minute intervals, you can see here we've got data for every single instrument on IG's account, or IG's trading platform that has data for that instrument, and you can see it go all the way down. So if we go here, you can see that. You can see in some cases you've got like instruments like these that have hardly any data. But then you might have instruments like currency exchanges or currencies that are fairly big. Yeah. Okay, so let's try running this code, and then you can have a better idea of it working, and then I can talk you through the debugging process and show you each step as it goes. So let's choose a date. Let's say 21 of the 05. Let's go from 10 to 12. Yeah. Okay, so I'm not gonna go over the increment API key because I've spoken about that in another video. You just have a look at that, and I don't really want to show anyone my API keys, because it's not credentials. So if we skip that part out and just jump to here. Okay, so if we read that data in, you'll see that our instrument here, you can see that we've got this column here, unnamed, which is basically like an index for the ID code for the value or line value in the CSV file. So you can see here, if we remove it, then you can see instrument. You can see we've got epic codes here, and we've got about 16,090 epic codes or instrument values that we have in this file. Cool. So if we convert that to a list, we then have a list of epics and you have a list of names, each paired equally to each value. So if we, for example, take list of epics value 2, the list of names value 2 will be of the same type, so that way we know what's what. So if we, I should change that, 5. So you can see we've got a resolution of that, and then let's see if we run that again, because it's going to throw an error. Well, not an error, but it's just a very large date value. Yeah. One more other thing to bear in mind is that the end date must be larger than the start date, right? You can't go in reverse. It has to be that way. So here you can see end date, start date. In this case, we're just doing one date, so we're only going to make one folder. And then you can see here we're going in at 0. Boom, boom. Yeah, so you can see that epic values for this instrument here. So another option. We're basically saying the number of data points we want is 9,000, or our limit. Actually, here it's irrelevant because we're just doing it by date. So we just want to know the number of data points between one date and the other. So this, I mean, ideally should be commented out, but I just kept it there because I think I was running another function that used it. But yeah, if we go through that, print the name out, see that, response is none, just kind of initializing it. You can see here that we're just running the function, and there you can see there's no historical price data not found. So that was basically there was no data available. Break is equal none. Yes, it does. So we then go back. We then increment to see what other instruments might be there. So weekly goal, future for 2005 core. Does that give anything? So a breakpoint there, breakpoint there. Yeah, and then we'll keep going until we get some data. So weekly goal, Feb futures call. So if we print out the response, you can see we've got this data here. Right. So if we then go step into that and we get the content we want, so you can see here we've accessed the data frame from response prices, and we've stored that into date frame of prices. So right, so if we say something like type, you can see it's a data frame object. So yeah, we've got what we need, so you can access the data frame that way. So you can say data frame bid. So one thing to bear in mind with this data is that it's piled in a hierarchy. So you have bid and you have an ask. Was it offer? Give me a second. Last. Bid and ask. Okay. No. Try them please. Okay, yeah, so you can see these two, right? So they're hierarchy based, so you have to go ask, and then when you get into the ask, you have to go open, high, low, close, blah, 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 and vice versa. So if you can bid as well. So yeah, you can see that. And then now if we save that to a file, you can see here that we've passed those parameters into this function. We're then trying to see if we can convert anything that was of a / or a dash. We then create that. If the path doesn't exist, then make one. So if we go into that, we go into data IG instrument, historical data 5 minutes. Right, so we make it. Error, I cannot create file when that file already exists. Oops. Alright, so you can't make 5 minutes false because obviously the directory already exists. Then we then make the subdirectory, which is yeah, so the try and catch statement essentially is like it's a safety net for us. So if we're unable to create this section here, then it just gives us an error instead of crashing completely. Yeah, so then we then create the whole directory, which is the date value there. So you can see there. And then if we then go into that, we then save that data frame to file, and you can see it's saved it. And then you can see our value here. And then you can see it's saved in this form. Cool. So then, yeah, let's go into it again. So you can see the other day it was another call, and if you go into that, you can do the same sort of thing. Data. You can see each one has data to it. Most of them are called. So let's just get to a point where an error does occur. Yeah. Okay, great. So what happened? So we tried getting this, but it says public API exceeded API key allowance. There was no data available. So in this case, we've exhausted all the possible our API data limit. So now, if we loop into this function login, we'll then create ourselves another expiry time. I've kept that to an hour because it seems to throw less errors. When I try to, ideally, if you want to make it long, like maybe a day or two, you'll say 24-hour times by. You can say 24 hours or whatever, but I just found 1 hour works best for me. So what works, leave it, right? So do that. Create an expiry time. We then create the session that we have. We then go into our API key increment, which we then increment over by 1. So you can see previously our counter value is 0. So then we would have a global variable here, which is basically connecting that counter value to the global variable in this file or in the program. You then increment that by 1, so it gets to API key value or index value of 1. We then take that from this file. We then print that key. We then put that key to this value here. We then close the file, return the key back, and then we get that, create an object, create a session, and return that key back. If that works, it works, and then we continue on. And so, to have proof that it works, if we say run, you can see it came back with a response for the same value. So if we say response, so that's the value or data for that particular instrument. Yeah, so if we let that play for some time, you can just kind of watch it. Oh, and if you have a look at the data coming into the file, just to let you know what it looks like, you can see data being popping in here. Okay, so to give a bit more of an overview of the code, because last time someone told me that it wasn't easy to understand what was going on. I'll make this a bit more broad and summarize it by function. So you've got the login details here. You've got your counter increment set to -1 here because as soon as they get into the function, you +1 to the counter, so automatically it goes to 0. You then got your login function here, which is essentially needed every time you do an IG request. You've then got your main page, which is the main meat of the code. It's where you log in, or it's when the program is called and you then log in from there. You've then got a file here you're accessing to get the instruments. You then convert those instruments to a list. You then specify the details for your date, for your historical gathering function, so your resolution, your dates, and you then loop over each instrument that way. You then gather your data, you check if that data is valid, if no other data was thrown against it. So for example, if an error was thrown, like historical data are not allowed, or you've met your allowance, in that case we then run a login function again to get ourselves a new API key. We then have response, check that, and we save that data. We then have a save to file function here, which we save to the folder, and yeah, we create any new folders that we need from there on. We then have an increment API key function, which is essentially to loop over the API keys. Yeah, one other thing to note for this function is that there may be a case where you run out of API keys, or you reach the very end of the file and your API keys have all been used, or it's looped over every key. Obviously, when it's reached its limit, you have to loop back to the beginning to check if that works. So that's what this does here. Our counter then equals -1, so when we go back into the function we can +1 to that and get back to 0. Yeah, so one general advice is, if you find that you're getting stuck in a loop and you're not going anywhere forward in terms of getting historical data, just try and generate more API keys. The more the better. Just think of it. Another thing to bear in mind is each month, I believe I think it's each month or each week. No, I think it's each month. The API keys reset their data allowance. So each API key that has 10,000, if they go down to 0, the next month they'll replenish and go back to 10,000. Yeah, I think that's everything I could really go around this program. I'll try to give as much depth into it as I can. Hopefully you have an understanding of how to get historical data. Yeah, so that's as much as I could get from this tutorial. Yeah, thanks for watching.